synchronize ordering of tasks that get put onto a shared data structure, a list. We had a container that was basically managing questions, and when the questions would get filled up on that list, then we would have to wait until those questions were answered and cleared away to make room for more questions. So that was a simple use case representing the producer-consumer pattern. And the core of this pattern is the shared data structure, right? And we were using that as sort of like a queue, but it wasn't officially a queue because we had to code up the logic for retrieving the next element. We were getting at the 0th index position every time, as well as managing the capacity. We had to code up logic so that it doesn't overflow the capacity, and we set a capacity of 5 using that limit variable. So there was some coding logic involved in making that list behave like a queue, and it was not thread safe. We had to use the synchronize keyword as well as use the wait and notify methods to interact with other threads for releasing the lock on that shared data structure. So a better approach to the producer-consumer pattern is to utilize the concurrent utilities that Java comes with. And since the primary structure used to manage the producer-consumer pattern is a queue, we're going to use something called the ArrayLinkedBlockingQueue. That is concurrent out of the box, and it comes from the concurrent package. And so using that, we don't have to use the wait and notify and setting a limit to the number of things that can go into the structure. That is pretty much handled automatically right out of the box by the ArrayBlockingQueue, which is the core of the producer-consumer pattern. So let's go over another example using the ArrayBlockingQueue, and I'm going to create a new project here. Just right-click and go to New, Java Project, and we'll just call this Learn Concurrency Utils or Utilities, because within the same project I'm going to be going over the executor framework. So just hit finish, and I'm going to create a package, and this package is going to be called com.jobready.producer-consumer. So the first thing I'm going to create in this package is a class. We'll just call it application, and this is going to be where our main thread initiates from. So it's going to have the main method in there, and then I'm going to also create a new class called producer. Hit finish, and I'll also create another class called consumer. So like before, the producer is going to implement the runnable interface because this is essentially going to be a thread. And I'm going to hover my mouse, add unimplemented methods, and I'm going to do the same thing to the consumer. So we'll put the run method there and then put implements runnable. Now in the previous lecture, we used the array list as the common shared data structure between the producer and the consumer. The producer was putting things onto that array list, whereas the consumer was, consuming those things off of that array list. So we're going to have a similar situation here in the application class. I'm going to define the structure, the shared structure, but instead of it being an array list, it's going to be called the blocking queue. So I'm going to define a variable of blocking queue, and it's going to be it's storing integers. It's a collection that belongs to the concurrent package, and I'm just going to call this question queue, and it's going to be new array blocking queue storing integers. And just hit the Control-Shift-O to bring in the array blocking queue as well as the blocking queue from the java.util.concurrent package. Okay, you want to be using the concurrent utilities going forward. It'll make your multi-threading life a lot easier. Multi-threading programs are hard enough to write, so using the concurrent package, the stuff in there is actually very useful and makes multi-threading easier. So this array blocking queue, notice, is giving an error, and it's saying that we need to add arguments to this. So if you go to the class definition by control clicking it, and if you do a control find And if I just type public and the word array, that's going to take me to the constructor of the ArrayBlockingQueue class. So let's hit find, and there you go. This is the constructor, and notice that it expects a capacity, right? This is the limit that we were manually setting up in the previous lecture. The linked list, we were saying that the linked list can only store 5 things at a time, 5 tasks at a time. But in this case, we don't need to set that limit variable or any other variable to maintain the space that we have in the array, in the queue rather. In this case, this is going to accept the capacity and maintain that for us. Okay, so we don't have to do those if-else checks. If the capacity is full, then wait. We won't have to do that. It'll do that out of the box. So I'm going to set for now the capacity to be 5 at this point. So when things are being put onto this queue, 5 is the maximum number of things that can go on here until they're removed. But we won't have to say, hey, wait until these 5 things are until we have room. It'll automatically wait until there's space to put things on the queue. We won't have to specify the wait and notify. So I'm just going to set this class up here for us just so that it's ready to run. I'm going to define a thread. We'll call it t1 is equal to new thread. And as an argument to this, it's going to be the new producer. And we'll come up with the constructor in just a second. And then thread t2 is equal to new thread. And it's going to have the consumer. And then we're also going to, of course, we'll have to start these threads. So we'll start T1 and we'll start T2. Okay, so this queue is going to be shared amongst the producer and the consumer. So I'm just going to pass in as an argument to the producer and the consumer. And of course, we have to define the constructor for both of these. So let's go to the producer, and I'm going to define a constructor. We'll do public producer, and it's going to take the blocking queue of type integer, and I'll just call it question queue. And this guy is actually also going to be defined as a member variable of this class. And we just do the Control-Shift-O to bring in the import. And there we go, that's our blocking queue. And then I could just do this dot question queue is equal to the question queue that was passed in to the argument of this constructor. Okay, so back in the application class, this should be compiling fine. We're going to do the same thing for the consumer. So I'm just going to copy this code right here and dump it into the consumer and change this producer to the actual class name consumer. So let me just paste that there, and everything else should remain the same. And now this application class is working, is compiling. So now going into the producer, we're going to be using the same use case we used in the previous lecture, where we have questions coming in and we have a consumer that's answering those questions. So the producer is producing questions and the consumer is answering those questions. So what I'm going to do is I'm going to define in this class a variable. We'll call it int. It's going to be of type int, and we'll call it question number. And this, of course, if we don't give it a value, it defaults to 0 at start. And then inside of the run method, if I do question no ++, and then later I add this to the question queue, I do question queue dot, instead of the add method, we want to use the put method. This is very important. Make sure you use the put, not the add, because the put is actually going to be thread safe. So we'll use that, and we add in the question number, and this is going to throw an exception, interrupted exception. I'm just going to surround this with a try catch. Now, there's something wrong with this code. Can you figure out what it is? Notice that we're running this first, okay? And remember, what is this? This is 3 steps. It's not just one step. This is 3 steps. It's reading the question number. It's going to add 1 to it and then assign it back to this variable. So within those 3 steps, this thread may be put to sleep, and the processor may allocate the control to another thread. So while this is being assigned, in the middle of that, some other thread may take over and and screw the order up. So we want this to be an atomic process, right? We want this to be just run all or nothing. If part of it runs, we don't want that. We want all of it to run or none of it at all. So there's a risk here of this not being thread safe. But then you have to ask yourself the question, does that even matter in our example here? Because if you only have one thread that can possibly run through a code path, you do not need to make that code path thread safe. And if you really think about it, this is just going to be one code path that's executed by one thread. Remember, we have a consumer thread and we have a producer thread. The consumer thread is not involved with incrementing at all, right? The consumer thread just removes things off the queue. The producer thread is the only thread that's involved with incrementing the value of this question number. If we had 2 producer threads or 3 producer threads, then we would have a problem. But in our situation, we've just got one producer thread and we've got one consumer thread. So incrementing here shouldn't really be a problem. Now, if I was to take this question number plus plus, incrementing inside of the put call, right? When we're putting the value inside of the question queue, while we're putting it, we put the question number plus plus there. Then what is going on? It's going to actually insert into the queue the question number and then increment it. This would result in the same thing, whether we increment it outside of that or inside of the put call. It doesn't matter. It's still a 3-step process and it's not thread safe if we have multiple producers. But in our situation, we just have a single producer. And we don't care if it gets put to sleep midway through incrementing the question number. We know that we're still always going to get the next available number. We're not going to have any duplicates or miss any numbers. But it brings up another point that if we want to print what we inserted into the question queue, let's say, we can print to the screen that we got a new question, right? That should also be part of this insertion. So it would be good to have this printing as well as the incrementing and insertion be an atomic operation. And the only way really to do that is surround a synchronized block around this question queue put command. And after this put command, we also print to the screen that we've inserted that question number, and that's really the most thread safe way of doing this. So the incrementing, the insertion, and the printing would have to be inside of that synchronized block. But let me show you another alternative, and I'm going to bring this up to prove an important point, which you'll understand in just a second. Instead of doing the incrementing here, what if I define a method outside of this run method? I define another method, and we'll make it a private method because we don't intend to use it outside of this class. And it's going to be a synchronized method. And let's just say that this method returns the next integer. And we could just say the next question rather, and we could just say get next question. And in the body of this method, here's where we're going to be doing the incrementing and the printing to the screen. So we could do int next question is equal to question number plus plus or something like that. Okay, and then after that, we're also going to print to the screen that we got a new question, and the new question is called next question. Okay, and this is of course just an integer. We don't care about actual questions here in this example. So we're going to return that same question. So this get next question invocation can be made inside of this put call. Okay, and I'm going to ask you a question here. If you think deeply about it, hopefully you're able to figure it out. Is this still 100% thread safe? I mean, this is a synchronized code block, right? This is a synchronized method call. So everything that happens in here is atomic, right? Doesn't matter how many steps there are in here. They're all going to happen, or none of them are going to happen at all. So it's an atomic operation. We're incrementing, we're printing to the screen, and then we're returning that next question. And we are invoking this inside of the put call of the question queue. So we're inserting the get next question value, whatever this returns, into the question queue. Well, believe it or not, this is still not 100% thread safe. And again, we only have one producer thread, so we're really going overboard with our thread safety. But when we're talking about threads, you want to consider thread safety. Even if you think that, we won't run into a problem. In our example, we won't run into having two producers. We just have one producer and one consumer, but in terms of thread safety, when you're writing multi-threaded programs, you want to be as thread safe as possible. This is still not thread safe because the printing and the incrementing that's going on here, this is an atomic operation. But after this is returned, the thread may be put to pause, but may be put to sleep before it actually makes its way into the question queue. This is going to return the next question, but before that question is sent to the put command, this thread may be paused, and another producer thread, if we had one, would come in and insert the wrong number. Okay, so we would have a problem there if we had two or more producer threads. So the solution here, which is not the best solution, I'll show you what the best solution is in just a second, but to correct this problem, I'd have to surround a synchronized block like that. Okay, I'd have to use a synchronized block during this insertion into the question queue. And now this is 100% thread safe, but in terms of coding this, codability standpoint, this is not a good way of synchronizing, because notice that we've got two synchronization blocks here. The get question is going to return the next int, and it's going to be synchronized, going to print and everything. But we've got this insertion also in the synchronized block. So we've got two synchronizations going on here, one inside of the other. And you'll see this in practical code when you read other people's code. This is a red flag. Okay, this is going to slow your application down significantly when you're overusing the synchronized keyword everywhere. In this case, it's not necessary to be having two synchronized blocks like this. So how would you improve that? Take a moment, pause the video, and try to improve this on your own, and then you can resume to watch my solution. Okay, so hopefully you were able to refactor that. The best way to do this is just simply get rid of this get next question method. We don't really need this. This synchronized block, we'll leave it as it is because we need to synchronize on the actual insertion. But outside of here, I can, do something like this. We'll get the next question number, and then I can print that we got a new question, and I'll put that next question inside of the queue. Okay, and then we don't even need this method at all. And now we're not using two synchronized blocks. We just have a single synchronized block in which we're incrementing, we're printing, as well as inserting into the queue. So now this is not only 100% thread safe, but it's also, a better solution than you just saw a couple of seconds ago. Coming over to the consumer, I could just print out that the question was answered, and then append to it the question queue dot take method. Okay, so what this take method does, if you hover your mouse here, first we need to surround this with a try catch because it can lead to interrupted exception. Now, if you hover your mouse on take, notice what it says. It says retrieves and removes the head of this queue, waiting if necessary until an element becomes available. So this is going to not only retrieve the element, but it's also going to remove it from the queue. So that's our way of saying that we've processed the question. We've answered it, and let's just remove it off of the queue. So two thread safe methods, the put method and the take method. You don't want to be using add and remove. You want to be using put and take for this array blocking queue. So let me just get rid of this inside of the catch clause. And so if I run this application right now, it's only going to do this once. It's going to, let me just show you what I mean. Let's just hit play. And there we go. It says we got a new question, 0, and we answered the question, 0. So this doesn't show the power of this queue at all. So let me do this in a infinite loop. If I do while true, and surround all of this code in this loop. This is just going to run indefinitely. And I'll do the same inside of the consumer when we're processing those questions. We're answering them and taking them out of the queue. We're going to put a while loop around that as well. And now this queue is going to behave as expected. And let's just hit play. And boom, notice there's, it's flying through this, but it's doing what it's supposed to do. It's using this as a shared data structure across both the producer and the consumer. And if it gets filled by the producer, the question queue is automatically going to wait. All right, because this data structure is thread safe. It does all of the waiting and notifying on its own. And the consumer is going to be taking things off of this queue. So let me close this and make it a bit more realistic in a way. If we go to the consumer, and if I tell this thread to sleep, and let's just say 1,000 milliseconds, it takes about 1 second for us to answer a question, or for some program to answer a question. So let's just hit play again, and boom, notice that now it's behaving in a way that you can easily read it, but it's still working as expected. So always remember, you've got a better way to do the producer-consumer pattern now by utilizing the ArrayLinkedBlockingQueue in the concurrent package, the java.util.concurrent. So because of this, we don't have to use the wait and notify methods. Those are being taken care of for us in the ArrayLinkedBlockingQueue. So in our example, we're just having a single producer and a single consumer, the producer thread and the consumer thread. But always remember that the producer-consumer pattern can have multiple producers and multiple consumers. Okay, it doesn't have to be just a single pipeline type of execution. We can have multiple producers producing stuff, and we can have multiple consumers consuming stuff. And we want to make sure that the producer that we create is thread safe. So when you run multiple instances of that producer thread, that will not have interleaving problems amongst the shared data. In the example that I presented to you here, since we have a single producer and a single consumer, it wasn't absolutely necessary for us to make sure that the producer is thread safe, but we went the extra mile and ensured that it was by using the synchronized block, making sure that our operations in that class are atomic, so that if there was ever a case where we needed multiple producers, we wouldn't run into interleaving issues of threads. In the next lecture, we're going to get into thread pools and using the executor framework, which is also part of the concurrent libraries of Java. So stay tuned. I'll see you soon.